Hi learners. So today we'll be discussing the effect of feedback on the control system. We have already discussed that there can be two types of the system, open loop and the closed loop type of the system. In open loop type of the system, there is no feedback, and in closed loop type of the system, feedback mechanism is there. And we have seen that in a number of ways, closed loop type of the system are more beneficial as compared to the open loop type of the system. So how the feedback affects the performance of the control system, that will be discussed within this lecture. We can very well see that feedback can be of two types. It can be a positive feedback, that is shown over here. For this particular block diagram, the overall transfer function will be given by G divided by 1 minus GH. The feedback from the output side can be a negative feedback. It is shown over here. For such type of the diagram, the overall transfer function is given by G divided by 1 plus GH. Now we'll just consider this negative feedback type of the system, for which the overall transfer function is T, that is TS, which is the ratio of CS divided by RS under zero initial conditions, and CS is equal to TS multiplied by RS. So the overall gain depends upon the overall transfer function T. So if the value of 1 plus GH, that is because TS is equal to G divided by 1 plus GH. So if denominator becomes less than 1, obviously the overall gain will become more. And in case denominator is greater than 1, then the overall gain of the system will decrease. So this is the effect of feedback on the overall gain, and how it is affecting, because in case GH is negative, 1 plus GH will be less than 1, and G is the transfer function of the plant that we cannot change, but H is the transfer function of the feedback link. So we can change it in order to make GH negative. In case GH is negative, 1 plus GH will be less than 1, and the overall gain can be accomplished by us. Now, the effect of feedback on the sensitivity of the plant. Sensitivity is basically to get that how the system is sensitive to the change of a particular parameter. So like in case we want to define the sensitivity of the overall gain to the variation in the open loop gain G. T depends upon the transfer function of the system, and it also depends upon the transfer function of the feedback link. For example, the system is changing, like there are certain changes in G that may be caused by the G is the transfer function of the plant. That may be caused by the various disturbances which are entering into the system. Like it can be caused due to aging, like in case we are having a thermal power plant, there we are using a boiler. There is a scale formation on the walls of the boiler as long as it is used. So that results in the variation of the performance of the plant. So that is reflected in G. Similarly, if we are saying that this is a thermal power plant, there can be variation from the load side. There can be variation from the input side. So there are a number of disturbances also that can be entering into the system, like there is a change in the load demand, or there can be a change in the load supply, fresh load. The old load of coal is being replaced by the new coal, a new supply of coal. So likewise, the disturbances can be from inside the plant. It can be from input side, these can be from output side, but at the same time G is also varying. This variation may be caused due to the aging also. So how the overall transfer function is varying with the variation in G, that is basically the sensitivity of the plant, and it is defined as curl T by T with respect to curl G by G. That is the percentage change in the overall transfer function that is caused by percentage change in the plant transfer function. So if we just put the value of, it can be written as, we have simply mathematical manipulation is being provided over here. This is equal to curl T by curl G into G divided by T. Then we substitute the value of T. T is G divided by 1 plus GH. G is as it is, curl T by curl G. We have calculated to be equal to 1 plus GH square. We substitute all the values within this. Then we get the value of sensitivity of the overall transfer function to G. This is equal to 1 divided by 1 plus GH. Now, in this case, we can very well see that how the sensitivity is affecting the overall change in the transfer function that is caused by the plant transfer function. Similarly, if we calculate the sensitivity of open loop transfer function with respect to G, then for the open loop transfer function, the overall transfer function is equal to G. If we calculate curl G by G with respect to curl G by G, so sensitivity of the open loop plant, it will come out to be equal to 1. So for the open loop plant, sensitivity of T with respect to G is 1. For the closed loop plant, this is equal to 1 divided by 1 plus GH. So it means that for the closed loop plant, the sensitivity has reduced by a factor 1 divided by 1 plus GH. Means it gets divided by 1 divided by 1 plus GH. In case 1 plus GH happens to be positive, so sensitivity of the plant, sensitivity of the overall transfer function to the sensitivity to the plant transfer function, it will reduced. So it means that sensitivity is also affected. It can also be improved with the provision of the closed loop transfer function. Then effect of feedback on the stability. Now, what is stability? Stability is defined in two ways. First is the Bibo stability criteria, which says that if the system is producing a bounded output for the bounded input, then it is said to be stable. Then we can say if the output is under control, then it is stable, otherwise it is said to be unstable. So overall transfer function of a closed loop system is with a negative feedback. We have already seen that this is given as 1 divided by 1 plus GH. Here we had calculated, it is coming out to be 1 G divided by 1 plus GH. So what is T? T is overall transfer function. So CS is equal to TS multiplied by RS in case RS is bounded. So in case TS is bounded, then CS will also be bounded. But TS depend upon the value of G divided by 1 plus GH. G is the plant. The only thing that we can change is H, that is the feedback element, the transfer function of the feedback element. In case H is chosen in such a way that GH is equal to -1, this element becomes equal to -1, then the denominator of this function will become equal to 0, TS will become equal to infinity, CS is equal to TS multiplied by RS, so CS will also become equal to infinity. So although RS was kept to be bounded, but CS is not within bound, so we'll say the system may become unstable. So it depends upon the value of GH, how much output that we are obtaining. So stability is also affected by the provision of the feedback. If GH is equal to -1, that's what I've told, the output of the negative feedback control system, it will be infinite. So the control system may become unstable. But in the case of the open loop type of the system, we do not have a feedback element. So CS is equal to GS multiplied by RS. So in case RS is bounded, it is multiplied by GS. So so RS is input, GS is the plant transfer function, CS is equal to RS multiplied by GS. So if RS is bounded, then output will also remain bounded. Then we can say that open loop systems are generally stable in case GS is chosen in such a way that CS is within our limit of stability. Limit of stability is to be defined by us. In case we say that there is a particular system that can carry a current up to 5 ampere and the current is becoming, that is the margin of stability. In case the current is becoming more than 5 ampere, the system is said to be unstable, because we do not expect the system current to become more than that particular expected value. So we have the we can choose the feedback properly so as to make up the control system stable, because in case GH is equal to -1, obviously the output will not remain within bounds and the system has a tendency to become unstable. Then the effect of feedback on the noise. So here we are having the overall transfer function. Within this transfer function, noise is entering into the system like this with the help of this block. So RS is the reference input, CS is the output. So what is the effect of feedback on the plant? For that, we will calculate the transfer function of this plant with respect to noise. So CS upon NS, CS divided by NS, we are taking RS is equal to 0, because when we are using the transfer function approach, we can consider one input at one time because it is applicable to the CISO system only. So CS divided by NS, this is equal to GB, that we can see. Here we are not getting anything, so we are simply getting CS out just because of NS. It gets multiplied by BS, so CS divided by NS is equal to GB. Then if we just take up the effect of feedback on the closed loop type of the system, here RS is kept equal to 0. But if we now calculate CS divided by NS, it will come out to be, here in the forward path, we are getting GB, but in the feedback path, we are getting minus H multiplied by G. So the overall transfer function of this system, it becomes equal to GB divided by 1 plus GA into GB into H. So GA and GB correspond to the plant, but we can select H in such a way that this becomes as high as possible. So the effect of noise is, because in case it denominator is becoming high, then CS upon NS, this is becoming almost very less, because in case denominator is high, the overall function will become less. So it can be made very less by the suitable choice of H. So the effect of in the, however, in the case of the open loop type of the system, we never had such type of the provision. Here the effect of noise is reflected within the system. This is equal to GB only. But in case we are having the effect of feedback on noise, we can very well see that the transfer function with respect to noise has been divided by a factor 1 plus GA into GB into H. So in case this is chosen properly, then the effect of feedback on the noise can be reduced to a minimum. Then next is the effect of feedback on the speed of response of the system. Let us consider a first order system that is having a transfer function 1 divided by S plus alpha. So if we just apply a unit impulse input to this transfer function, so unit impulse response is, it will be given by Ys is equal to, because Rs will become equal to 1 in that case. So Cs will, Ys will become equal to 1 divided by S plus alpha. If we take up the inverse Laplace transform, then Yt will be equal to e to the power minus At. So it means that in the case of the first order open loop type of the system, output is decaying with a time constant equal to 1 divided by A. So obviously that is what is required now, because we are saying that the system is stable. System is stable. So it means the first criteria is that for the bounded input, bounded output is produced. And for the second criteria is that in the absence of the input, the system output has a tendency to go to the zero value. So it must decay, because, and when we are taking a unit impulse, it's having a value at t equal to 0, 1. It's having a value equal to 1 at t equal to 0. And for all other values of times, its magnitude is equal to 0. So in the absence of the, so it means that the input is present only at t equal to 0. For all other value of time, it is equal to 0. So the output must have a tendency to decay to the 0 value. In the case of the open loop type of the system, it is decaying exponentially with the time constant equal to 1 by A. Now, similarly, if we get the unit impulse response of a first order system that is having a unity feedback, so Hs we have kept equal to 1. So overall transfer function in such type of the system, it will be given by 1 divided by S plus A plus 1. So if we take up the response units impulse response of such a system, it will be given by ys is equal to this multiplied by 1. So ys will become equal to 1 divided by s plus a plus 1. So if we take up the inverse Laplace transform, it will be given as yt is equal to this. So this is equal to minus e to the power minus a plus 1 into t. So in this case, the time constant is given by, this is e to the power minus t tau. No? Tau is the transfer function. The tau is basically the time constant. So tau minus e to the power minus tau by t by tau hota hai, the output. So it means the time constant is equal to 1 divided by a plus 1. So here it was 1 divided by a. So the time constant of the system is becomes smaller because of the provision of the feedback. And time constant simply specifies the speed of response of the system. It is basically defined as the time taken by the system to reduce to 63.7% of its final value. So since the time constant is reduced by the provision of the unity feedback, so the system decays to zero faster and the system response has become faster. So in the closed loop type of the system, we are getting the better speed of response. That is the effect of feedback on the response of the system. So we can very well see that what we have just covered within this lecture, we have seen the effect of feedback on the overall gain. Then secondly, we have seen the effect of the feedback in the presence of the noise, then the effect of the feedback on stability, effect of the feedback on speed of response, and we have just simply concluded that the presence of feedback helps in improving all such qualities of the system. So further, we'll be continuing in the next lecture with lot of thanks.